Good morning, everyone. Today is Monday, April 27. I hope you guys had a lovely weekend. So we're entering week 5, day 1. As always, you will see the PowerPoint to my left side and the worksheet to my right. So let's get started. All right. So the agenda. The first thing on the agenda, always do the do now. That's a form of checking in with me every day. So doing the do now, that's on Google Classroom. Then we'll go over the learning target, the success criteria, overview of the assignment, what you need to do, and go over some important vocabulary. And then I'm going to model how to do the worksheet that's on the right side of my screen, or your screen as well. So let's go straight into the learning target. So the learning target for today is, I am learning to differentiate between 3 stages of matter. In order to know that I've completed and reached that learning target, you're going to be able to define what's matter, what's a solid, liquid, gas, and you're able to differentiate between solid, liquid, and gas using images of atoms. Okay, so once again, welcome to day 1 of week 5. Today's lesson we will be identifying solid, liquid, and gas using images of atoms. And in order to do this, you're going to do some sort of closed reading. Closed reading is so important, and you're going to be doing this for every assignment that we give you, that teachers give you. So you're going to, as you can see from my right side, the small little article, you're going to be reading this 4 paragraphs. As you're reading, make sure to highlight and any important information that you're going to need. Like I said, I will model this in a bit. So let's go and let's start with the vocabulary. What is matter? What is a solid, liquid, and gas? Because if you don't know what that is, then doing the worksheet is going to be a little bit difficult. So let's get started with vocabulary. Vocabulary, matter, solid, liquid, or gas. So what a matter is, if you look at the PowerPoint, a matter is made up of tiny particles also known as atoms or molecules that are constantly in motion. So these particles, they're never still. They're never like still. They're always kind of like shaking a little, or shaking a lot, or shaking like crazy. There are 3 forms of the matter. There's solid, there's liquid, and there's a gas. So once again, matter. Matter is anything that takes up space. You are made of matter. Your bed, your computer, your phone, anything that you see is made up of matter. It takes up space. So matter is anything that takes up space, made up of atoms or molecules. And let's go to our first stage of matter, which is a solid. So a solid is anything that has a definite shape and volume. So something that doesn't change. So if we look at my phone right here. So my phone is always going to look like a phone. It's never going to change. It's not going to automatically turn into a remote control. What else? A case. A case is a solid, definite shape. Can't pass through anything. I can't change it to be a circle or anything. It's a solid. So as you can see from the PowerPoint, a solid state, the atoms, very, very tiny particles that if we had a microscope, if you could zoom in, you'll be able to see. These particles, they're tight, close together, and they're like shaking. They're shaking a little, they're bumping into each other, but they're so close to each other that it doesn't really move. Does not have that much room to move. So, a solid, it holds its shape and it has a fixed volume. Holds its shape, like I said, go back to my case, it will not change the shape. I cannot change it to be a circle. A fixed volume. This case will never get bigger. This case will never get any smaller. So it's fixed. It has a fixed shape, fixed volume. Another example that I have on the PowerPoint is ice. So you can see in this first image, we have ice in a pot. As this ice is getting warmed up from the heat, you can see that it's slowly melting and turning into our second stage of matter, which is liquid. So let's go to liquid. All right. So liquid. Liquid is defined as anything that takes the shape of its container because the particles slides past each other. Liquids have a definite volume. However, the shape can change. So if we look at my lovely little water bottle right here, this bit of water, if I were to put it in a cup, if I were to put it in a bowl, it's going to be the same amount of water. This water is not going to get any bigger. This water is not going to get any smaller unless I drink it. However, when I do transfer this water into a bowl or to a cup, it's going to take the shape of that cup or that bowl. So if I have a fancy little cup that goes in and out, well, that water is going to take that shape of the vase that's going in and out, or that cup that's going in and out. If I have a cup in the shape of a heart and I put that water in that heart, that water is going to take the shape of the heart. The reason it's able to do this is if you look at the middle picture right here where my cursor is, those particles, they're still together, they're still close enough, but they're able to slide around. So they're not close enough like the solid where they can't move. They're close enough so that they are able to move around each other. They're able to slide, and that's how it's able to take the shape of things, because they're able to slide, intermingle, and whatnot. So just like the solid can be melted, if we're talking about ice, just like the ice in the solid form is able to be melted to the liquid, that can also go reverse. We can have the liquid turn into an ice, liquid turning to a solid, which is the ice. What we have to do is we have to take away that heat, so that's why we put in the freezer, and wait for it to for the particles to lose its momentum and go back to being a solid. All right. Let's go to the next one. So when a cube, an ice cube, is heated, energy is going in to make it a liquid. And when more heat is added to the liquid, we get our third stage of matter, which is a gas. So as you can see from the PowerPoint, a gas can change both its shape and volume. The molecules move rapidly fast one another and have little attraction between the molecules, so that molecules spread out. I know that sounds a little confusing, but all gases is we have particles. These particles are separate from each other. So these particles are moving super duper duper fast, and they're bouncing off one another, creating collisions, moving around. So just like you see from the PowerPoint, you see like these particles, they might be close, but most of the time they're kind of just wherever. They take the shape of anything. They change their shape. If they're like in a balloon, will take the shape of the balloon, but they're still bouncing around. And it'll take the volume of the container. So molecules of a solid, really close, shaking a little, can't really move much. Molecules of a liquid, they're free flowing, they slide around each other, they take the shape of the container. And gas, they are going crazy. They're going crazy. They want to go out, just like how we want to go out because of quarantine. These gas particles, the same thing. and they take the volume of the container. All right, so then let's recap. So matter is anything that takes up space. They are anything that's made up of atoms and molecules, which is absolutely everything. The most common three stages of matter is solid, liquid, and gas. A solid has a definite shape and volume, meaning that it will not change, it will not grow bigger, it will not grow smaller. It's stuck the way it is. Liquid is able to change its shape. However, the volume or the amount of space it takes up will be the same. And gas, on the other hand, gas doesn't have like a infinite volume. It takes the volume of the container, and it's able to take the shape of the container as well. Okay. And let's quickly go over how we get these three different types of stages. So let's start with what we're familiar with, ice. Ice is a solid. When you add heat, it's going to melt and turn into water or liquid. If we keep adding heat to the liquid, it eventually will start to produce steam, and that steam is a form of gas. So ice will melt to water, and water will evaporate to gas if we continue to add heat. But what if I want to turn a gas back into a solid? Well, if we had to add heat to change it from a solid to a gas, then what do you think is opposite of adding heat? Yeah, we're taking away the heat now. So we're taking away the heat, which means we're cooling down the particles. So now we have gas that's going crazy. We're cooling it down, and it's condensing into water. So if you ever had like a cold glass of juice, soda, cup of water, you'll see that on the outside of the cup, you start having like these bubbles, not bubbles, I'm sorry, liquid. Well, that's the water vapor condensing from in the cup because it's cooling. Once we have that gas condense into water, or that gas turn into a liquid, we're going to keep cooling it down, and it's going to solidify to ice. So let's just recap. I get an ice cube, I melt it into liquid, and if I keep adding heat, that liquid is going to evaporate into a gas. And if I cool that gas, the water vapor down, it's going to form water again. So it's going from a gas to a liquid. And if I keep cooling that liquid down, so if I were to put water into the freezer, hours later, what do we get? We get ice. We get the solid form of that liquid. All right. So now that we kind of reviewed solid, liquid, gas, and how to get them, let's look at the worksheet. All right. So the worksheet, you're going to read each paragraph. You're going to highlight what's important. So definitions, very important. So we're going to highlight that. And what's also like, how is the atoms in each stage of matter? So you're going to read the 3 paragraphs. Once again, I always run out of time. And then you're going to look at these 4 images. Looking at the atoms of the 4 images, we have one that's going crazy, one that's really tight together, or actually not, kind of loose because you see little gaps, and others that are really tight together. Looking at those images, what stage of matter has particles going crazy? What stage of matter has particles that are loosely packed? And then the last part, you're going to tell me what stage of matter is this? How does it become this? And how does it lead